Okay, in section 3.5 here, we're now looking at relationships between sets of ordered pairs or data. So when we're looking at real world information, not everything works out really nice where our information forms a straight line and everything forms a perfect absolute value equation and all that sort of stuff. Real life data isn't that easy and simple. And so when I'm plotting information on a graph and things don't really form a straight line, they don't really form anything that looks like a decent pattern, that's usually what we call a scatter plot. It's a graph with points plotted to show a possible relationship between two sets of data. And because we're only really looking at two sets of data, there could be other information out there that affects it that keeps information from forming a straight line or from forming a curve or something that looks really nice. So a scatter plot is a nice way to look at that and kind of see what's happening, what relationship exists. So here's an example of a scatter plot. We have a table that shows the number of points scored by a high school football game. So here's our score for each of the first 4 games of the season. So first game they scored 6 points, second game 21, third game 46, and fourth game 34. Now our scatter plot is this graph over here, where I took my dependent variable, the game, and I graphed that versus the points scored, or my independent variable. And so as we look, well, it doesn't look quite linear because this one's a little low, this one jumps up high. And so we're not finding a big pattern there, but we see a pattern that as we play more games, the point scores somewhat increase. So we're going to create our own sample scatter plot. The table shows the number of cookies in a jar from the time since they were baked. Graph a scatter plot using the given data. So is time based on the number of cookies or cookies based on the number of time? Well, time is our independent variable, so we put time on the bottom. And it's always important when you're doing a scatter plot to label your axes. One of the number one things that students lose points for in AP statistics is not labeling their graphs. And we do a lot of this in AP statistics. So we've got 1, 2, 3, 4 minutes. And then we have cookies. So my cookies go as high as 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like I'm going to have to go by twos. So this is cookies. And we're going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So now that I have everything labeled, I can go ahead and plot my information. So after 1 minute, there were 24 cookies left. Now, 2 minutes, after 2 minutes, there's only 16 cookies left. So some people in the house got a little hungry. Now, after 3 minutes, there's only 10 cookies left. Looks like people like their cookies nice, warm, and gooey in this household. And then after 4 minutes, there's only 7 cookies left. So it kind of looks like there may be a curved pattern there. It may not, we don't really know, but that's our data. So it looks like as time passes, the number of cookies goes down. And so we describe that relationship as correlation, the relationship between the data values. So we have what we call positive correlation. Both data values are increasing. As x increases, our y's are increasing also, meaning that our dots are kind of going up. As we move to the right, the dots are going up. Because as x increases, that y is increasing also. Now, negative correlation is the opposite. One set of data values increases while the other one decreases. So as x increases, those y values are decreasing or going down, which means that the overall trend is going downwards. And then, of course, we have the no correlation. There's really no pattern. You can't really tell. You could make an argument for going up. You can make an argument for going down. You can make an argument for staying flat. Because there is no rhyme and reason, there is no pattern to that, There is no correlation, also known as like no relationship between those values. Okay, so now we're going to look at what type of correlation is existing. So in my first graph, as my temperature goes up, the number of visitors to the beach also goes up. So this is, and you can tell by the dots, they're kind of going up. This is a positive correlation. Now in our other graph, as the number of missed classes goes up, the test scores are going down. So the more classes you miss, the lower your test score is. And this is a negative correlation. Okay, so now we're going to think about what would you expect to see? What type of correlation? So the average temperature in a city and the number of speeding tickets given in a city. So would you expect as temperature increases, speeding tickets to increase, decrease, or there is no relationship? Now what's interesting is that as temperature increases, people with convertibles and race cars, they tend to get out driving more and they drive fast to get more of a breeze and all that. So what actually ends up happening is as temperatures increase, the number of speeding tickets increase. So this would be a positive correlation. Okay, the number of people in an audience and ticket sales. So the more people you have in the audience, the more tickets you are selling. So this is a positive correlation. Okay, a runner's time and the distance to the finish line. So the longer that they are running, or the increase in time, the closer they are, or the lower distance they are to the finish line. Closer and closer, smaller numbers. So this would be as one increases, the other decreases. This would be a negative correlation. Okay, choose the scatter plot that best represents the relationship between age of a car and the amount of money spent on repairs. So the first thing I want to look at here is when I look at my first graph, I have -4 age of years. Is it possible for a car to be -4 years old? No. So that is definitely not possible. So now I'm looking at graph B and C, and I'm trying to decide, as my car gets older, am I going to have to spend more money on it? Or as my car gets older, I spend less money on it because these values are going down. And the correct answer would be that the older your car gets, the more repair costs you have to have. So after a certain amount of time, you have to replace your alternator, your battery, your, oh, God forbid, your tranny, because that gets really expensive. And so as more time goes on, the more your repair costs are going to be. Okay, next one. Choose a scatter plot that best represents the relationship between the number of minutes since the pie has been taken out of the oven and the temperature of the pie. So as time increases, the temperature is going to decrease. Sounds about right. Well, graph B is wrong because we can't have -10 time. As time increases, does the temperature increase? So over time, the temperature is the pie is gonna get hotter and hotter and hotter out of the oven. No, temperature decreases out of the oven. So this would be the correct graph. Things cool off after you take them out of the oven. So the longer it's out of the oven, the more that temperature cools. Okay, you can graph a function on a scatter plot to show a relationship in the data. Sometimes the function is a straight line. This line, which we're going to call a trend line because we're not using math to really calculate it, we're just kind of estimating. It can help show the correlation between data sets more clearly. And it can also help you make predictions based on the data. So if I'm looking at Valentine's Day orders, the date in February versus the number of flower orders, I can kind of draw a trend line. Now when I'm drawing a trend line, I want to try and make sure that I'm as close to my line is close to the dots as possible, but I have an even amount above and below the line. So I could be looking kind of like this. That might be a pretty decent trend line. So now that I've drawn a trend line, and keep in mind, this is just kind of an estimate. We're just kind of sketching it on there. We're not using math to draw an actual line. When we use math to draw those actual lines, it's called the linear regression, and it's the line of best fit. And we use graphing calculators most of the time to calculate that because the math is just so intensive. So if you have a graphing calculator, I could actually show you how to do that on the calculator. But if not, don't worry about it. In Algebra 2, you'll have to do that a lot. So you want to make sure that if you're going into Algebra 2, which is like a college level algebra, that you're going to want to make sure you have that graphing calculator. Okay, so we drew the trend line based on this relationship. Predict the number of flowers placed on February 12th. So I'm going to look at 12. I'm going to look at that, and it looks like it intersects my line up here. So if this is 25, 35, it looks like this is about 45. So based on my trend line, I'd say about or approximately, so that's a squiggly equal sign, kind of saying that based on our estimate, because everything here is estimating, about 45 orders. Okay, and that's our scatter plots.